we're actually going to start solving equations with these. But there's one important note, and it's up in that bolded box up at the top. You should find the domain before solving rational equations. In other words, are there any x values that make this undefined? And it's good to know that in advance, because then if you get an answer at the end and it is that particular value, you know that value is not going to work. Because I'll be honest, I don't want you to have to go through all of this stuff at the end of every problem to make sure that your answer works. All you really need to make sure of is, are there any values that cause me an issue? So like for instance here, if there's just a number in the denominator, no big deal. But once I start getting variable terms there, I have to pay attention to this. So like for instance, what number could cause me a problem if I plugged it in for x?
Negative 1.
-1, because -1 plus 1 is 0. So my domain is all reals not equal to -1. So if I work this out and the answer I get, or one of the answers I get, is -1, that's not an answer at all. I can't use it. So it just kind of gives me something to be heads up about. So I start looking over here and I'm like, okay. So I look, normally I'd find my LCD first with this. And remember, when you're finding a least common denominator, or a least common multiple, which we're going to do here because we're going to multiply by it, you're looking at 3 different parts. And I'm always going to put parentheses around my quantities to make sure I don't think of that in a different way. I'm always looking at coefficients. Well, if I'm looking at 5 and 10, my least common multiple would be 10. I don't have any single variable terms anywhere, but I do have a quantity. So if I were building this and I wasn't solving an equation, my least common denominator would be 10 times the quantity x plus 1. And you'll notice what happens over here is that we're going to multiply both sides of our equation by that denominator, by that multiple in this case. And I'm actually going to change that to m because since we're multiplying, I want to use the correct terminology. So least common multiple. And I distribute that through. And as I do that, whatever I would already have in my denominator would cancel out. So like for instance, the 10s here would cancel out, and I'd multiply the 9 by x plus 1. When I get to my second term, the x minus 1s would cancel out. So I'd multiply 2 times 10. The idea of multiplying by the least common multiple is to get rid of all the fractions. And then the 2/5, now this one's a little more interesting. 5 goes into 10 twice. So what's actually going on here, if I do a little side work, if I multiplied through, I'd have 20 x plus 1 over 5, because I'd multiply times the numerator. But this reduces. 20 divided by 5 is 4. That's where that's coming from. So I multiply through, get rid of all the fractions, and then I just work through my algebra skills and find an answer. But like I said, instead of doing all of this, what I'm going to do instead is I'm going to take that answer and make sure it's not one of my domain restrictions. If it's not, it's fine. It's good. Go on to the next problem. Don't put yourself through this every time. Because that's the only thing that could cause us any issues is it not part of my domain? And I know it says right below here, check your solution. I keep saying don't. Well, I would say instead of this, I'm going to change this slightly. I'm going to say know your domain first. Because that way, you know what values are going to cause you trouble before you ever start, instead of having to do all that extra stuff at the end. So like I look at number 1, and I say, okay, what values could cause me trouble? 0. Okay, so my domain is all reals not equal to 0. So as long as I don't get 0 for an answer, I'm good. So then I look and I say, okay, what's my least common multiple that I can multiply all the way through here by? 4x, because I have a coefficient and I have a single variable term. So I'm going to multiply all the way through here by 4x. So by doing that, I go, okay, well, in this first one, shoot, the 4x's cancel. I'm just left with the 1 in the numerator. I get to my next term, the 4 cancels, but the x is still there. So to try and make this jump a little, whatever is left in there, I'm going to start using red so you can see how this works. And then when I get to the other side, the x's would go away and would just leave me with the 4. And again, if some of you are doing this in your head and you know it's 28 right away, that's fine. I just like you to be able to see when we're doing the notes where everything comes from. So once I get there, now I'm just back to like Algebra 1. I just need to take a second here to do my, in this case, two-step equation. I make sure my answer isn't a domain restriction, and it's not. So I'm a happy camper. And that's all we're going to be doing throughout these. The biggest thing is going to be, are you going to get the least common multiple? We'll see. Do I have any domain restrictions in number 2? No, there's no variable terms in the denominator. So, woohoo. My domain is going to be all reals. So, no biggie here. What's my least common multiple going to be? 15. Because if I started counting by 3s and 5s, 15 is the first number I'm going to run into. So I start looking, I'm like, okay, 15 divided by 5 is 3. So I'd have 3 times the quantity that's already there. Doesn't mean that quantity disappears. Then I move to the second one. I'm like, 15 divided by 3 is 5. So I'm going to multiply my next quantity by 5. Notice the parentheses being a good idea because that number has to distribute to the entire quantity, not just the first term. And then the last one, there's nothing to cancel. So I just multiply the 1 and the 15. And I have to do that. Just because something doesn't cancel doesn't mean I leave it completely alone. So let's see here. Do a little distributing. Try not to go so fast that I do something silly. Because we've seen before, I can even do something silly if I get going too quick. Combine my like terms. And move my negative 29 to the other side by adding it. And divide by 22. And since I saw before there were going to be no domain restrictions, that works pretty well for me. But again, that key is going to be, how am I doing with my LCM? All right. Let's see here. I won't start getting more challenging quite yet. Let's do 3. We'll bounce around a little bit here in a moment. Restrictions? Negative 4. Because if I set that equal to 0, that'd be my causing of 0. And in these first few, that multiple that I'm going to multiply through by hasn't been much of a big deal because I haven't had a whole lot of choices yet. For my first 2 fractions, I've already got the x plus 4 there. So it just does its job by canceling out my denominator. It's not until I get to the 10 that I actually have to multiply by it. Because once I do that, then again I'm just working on and again, if you did the divide by 10 and said negative 3.5, that's fine. That's not one of those things that I'd go crazy over. So either simplest fraction form or that decimal form does not cause my domain to be a problem, so I'm okay. Now we'll start to make life a little more challenging. Maybe. Some of you had issues when we got to our last quiz with factoring a denominator if it could be factorable. I can't just look at this and say, oh, those are different, I'm going to use them both. Okay? I really don't want to do that. Now I could get away with, because there's two ways I could go after this, I could get away, since there's only one fraction on each side, by cross multiplying. And that would probably be my best bet. But if I was going to try to find my least common multiple, I'd need to factor these first. Before we get there, what restrictions may I have? Maybe it would be easier to figure out my restrictions if I actually factored my denominators out. I may not want to use them when I multiply, but it's going to definitely help me when I'm trying to figure out where those bad values are going to be. Where do the bad values lie? 1 and -1. So if I get either of those as an answer, that's trouble. And like I said, you could either at this point find the least common multiple and multiply, but I always say if it's just one fraction on each side, I'm going to cross multiply and just go after it that way. And here I've got 2 times 15, so that's where this 30 is coming from. You're like, now it's interesting, Harty. This one you took in the factored form, this one you didn't. That's just a personal preference matter. Because I'm going to end up with the same thing at the end, even if I'd have left this as 2x minus 2. Because you'll notice once I distribute, if I'd have left it, I had 15 times 2x is 30x. 15 times -2 is -30. So I'll still get to the same answer. But when I get to this point, if I want to make this easy on myself, all of my terms need to go to the x squared side. Probably going to have to do some factoring here. So if I start moving all of this over to the left, subtract over the 30x, and add over the 30, I've got this to work with, and I'm going to have to factor. But again, before you go and start working with bigger numbers, trying to play with the mental math, it's always easier if we follow the golden rule of factoring. If they all have something in common, they all have a 5, go ahead and factor that out, because it's going to make the numbers that you're working with to factor smaller. Factoring smaller numbers always is a better idea. So let's see here. Multiply to +5, add to -6. -5 and -1. And since my 5 doesn't have a variable term with it, I can't set it equal to 0. But I can set each of these equal to 0 and get what initially looks like my 2 solutions. However, yeah, I go back to that first step I did and I say, uh-oh, 1's in the bad club, can't use it. 5's the only answer that works. Because that's much easier to deal with than trying to plug those numbers in and see what works and what doesn't. The last one on this side may be the trickiest one. What are my 2 values that cause problems first? 0 and -2. Bigger question. What's my least common multiple, or what would be my least common denominator if I was trying to turn these into that?
X plus 2.
Yeah, those of you that said x squared plus 2x, you're right. It just might be easier to look at it this way. Here's what some of you have been having some issues with. Whenever you see a denominator where there's a plus or a minus term, you really want to put parentheses around it. Now, if you can factor it like you did in number 4, that's fine. But otherwise, I need to put parentheses, because otherwise we tend to mistake this x and this x for the same thing. But there's a difference. This one's bonded with that 2, with that plus sign. So that's a single variable, that's a quantity. They both need to be included when I'm multiplying through with my least common multiple. Because now as I start to distribute, okay, I've got my 12 here, but the x plus 2's cancel. Just leave me with the x. Then I get to my 3, the x's cancel. Leave me with x plus 2. And on the end, nothing cancels. And I need it all. So now it just becomes a big game once I have this set up, combining like terms, distributing, and starting to get everything where it belongs. And even on this, I like to write out this one step just to make sure I don't do anything silly. Again, I have a squared term. It's a quadratic. So I want all the terms to the quadratic side, to the 2x squared side. So I notice I have 15x here. So I'm going to subtract this 15x over. Subtract over my 6. I don't have any like terms this time. So I go, okay, hopefully this is going to be factorable. Otherwise I can go to the quadratic formula if I need to. Let's see here. Negative 6, positive 1, negative 12, plus 1. Okay. Set those each equal to 0. Subtract my 1 and my 6. Neither of them are in the bad list. I actually get 2 answers for once. It's a miracle. I want to take a look at one more of this type, just to make sure we're kind of getting a feel for things here. We're going to go over to number 8. So I want to make sure that every screwball thing that could happen to you we cover in one way or another. Because we've covered where this LCM can get to be a little bit of a hassle. Now I want to make sure that if we get to number 8, that doesn't cause an issue. Okay, here, factor, factor, factor. And I'm even going to cross these out as I get why I rewrote that one when it's the same thing, I have no idea. But the thing I wanted to stress on number 8 is that middle fraction. If you factor it out, it's x minus 3, x minus 3. It's the same factor, so I have to put it in as squared. Because then, in a moment here, when I go finding my LCM, I'm going to have to include the squared part, since in one single fraction I got the same quantity. Before we get there, now that we're factored, where are my issue values? 3 and negative 3. And my LCM is going to be x plus 3, but then since I have an x minus 3 that's squared within one fraction, I have to use the squared. If I only use 1, I'm going to get in trouble. So when I got to that second fraction, things aren't going to work for me. So x plus 3, x minus 3 squared. So I'm going to go through fraction by fraction and say, okay, I've already got the x plus 3, that's canceled. One of the x minus 3's is canceled. So I need to use the other one. Here, I've got the x minus 3 quantity squared. I don't have that other x plus 3. It didn't cancel out. And then equals, I have the x plus 3. I need the x minus 3 quantity squared. But notice again in that middle one, I put parentheses around the x minus 1. It's not just the negative 1 distributing. This has to be FOILed out. So this gets to be quite the interesting little... Now this is just my suggestion. I would put the minus here right now. I would FOIL this out and then worry about the signs later. So like here I've got x squared, 3x minus 1x is 2x minus 3. And then over here, reminder, x minus 3 squared is this. I'm actually going to write it back out so I don't get sloppy and think it's like a difference of squares, or write x squared minus 9 or something like that. And I can finally start to clean this stuff up a little bit. And it's so worth taking the extra line or two to go ahead and do this one step at a time instead of trying to do like 3 steps at once. All it's going to do is cause issues. Even at this point on the left side of my equation, I still have like terms that I haven't put together. I'm going to go ahead and do that. You're like, okay, Mr. H, you always say get everything to the x squared side. Well, both sides are the x squared side. Well, now I'm going to try to make it a positive x squared side. So I'm going to move everything to the left here. So I'm going to subtract the 2x squared. I'm going to add 12x. And I'm going to subtract the 18. And then factor what's left. So let's see here. Negative 5 and positive 3. X equals negative 3 and 5, but negative 3 is one of my no-nos in my domain, so I'm only going to get one answer. If you can find LCMs, piece of cake. If that's still an issue, well, that's something that needs to get taken care of somewhat soon so we can make sure we've got you in good shape. And finally, we get to the story problems. The applications that you will see again and again and again as you get into standardized testing, especially these first two. All right, let's get down to it here. The current in a river is 6 miles per hour. In her motorboat, Marissa can travel 12 miles upstream or 16 miles downstream in the same amount of time. What's the speed of the boat in still water? Is this a reasonable answer? Okay, so this is a classic distance equals rate times time question. But I want to take it one step further because it's not just one thing we're looking at. We're looking at two different situations, upstream and downstream. Since I tend to like things that are more visual, I'm going to make myself a chart here. So I got distance, I got rate, I have time. And I'm going to be working with two separate things within that. I'm going to be working with when I'm going upstream and when I'm going downstream. So I'm just going to kind of split this up a little bit more. So now I start digging through and I'm saying, okay, where can I plug the information in? The current in a river is 6 miles per hour. We're going to come back and use that in a minute. In her motorboat, Marissa can travel 12 miles upstream, sounds like a distance to me, or 16 miles downstream in the same amount of time. Okay, so we've got our distance. What is the speed of a motorboat in still water? We don't know. Here's one thing I do know. Same amount of time. Okay. We don't know what that time is, but we know whatever it is, it's going to be the same for both. So I'm just going to leave that as t. The rate's where life gets interesting. We don't know the speed of the motorboat, but we know this current. So if I'm going upstream, is the current working with me or against me? Against me. So whatever my rate is, I'm going to be losing 6 miles per hour because that stream is going to slow me down. When I'm going downstream, it's going to be at my back. So that's going to be r plus 6. And you're like, well, wait a minute, though. You have two variables. How are we going to do this when you have two variables? I have one that's identical, though. So here's how this works. We're going to solve this for time, since they're equal. So if distance equals rate times time, and my times are the same, I'm going to solve for t. So t would equal the distance divided by my rate. Because these are the same, these have to be equal. I'm like, oh, all right. So for my upstream, I have distance divided by rate. And that's going to have to equal the other one because I want the same amount of time. Distance divided by rate. And now it's just a simple proportional problem that I'm working with. Sort of like when we worked on that problem on the other side where we just cross multiply. And that's exactly what I'm going to do. I'm going to cross multiply here. And it's going to help me figure out what my rate is. So now we just got to solve for r. And we're going to find out we're going kind of fast. I was kind of surprised to see a boat going this fast, but maybe it's because I don't deal with boats very often. Divide by 4. Now I've got that the boat is going 42 miles per hour. Maybe my boat experts can tell me that just seemed awfully fast to me. But I have a way that I can tell that it works. Well, how are you going to tell it works? Okay. So if I were to do and plug in this 42 for r, let's see if it works. I look up here, if it's distance equals rate times time, I'd have 12. Now, where am I forgetting something? I had this written down before to where I wasn't going to. Oh, yeah. R plus 6. I'm going to start with downstream, actually. So R plus 6, 42 plus 6 would be 48. If 48t, let me get me a new. So for downstream, I'd have 16 equals 42 plus 6 would be 48t. If I solve for t, t'd be 16 divided by 48, or 1/3. If I looked at upstream, distance equals 42 minus 6 is 36 times t. Divide by 36. Okay, so we're looking at about 20 minutes it would take to do this, but I get that same t value out. So if I find that balance, it's something that's reasonable. It works. I can explain myself mathematically with it. Even if I don't understand how fast a motorboat should go or not go. Because I still think that's awfully fast. But that's how I can do it. The other one that shows up quite a bit is going to be work problems. Adam, Bethany, and Carlos own a painting company. To paint a particular house alone, Adam would take him 4 days, Bethany would take 5.5 days, Carlos would take 6 days. If these estimates are accurate, how long would it take the three of them to paint the house if they work together? Now there's a form to how these work, and here's how this goes. It works with an inverse. You take each of the times that these people have. So within a day, this guy could do 1/4 of the job. Bethany would be able to do 5.5 of the job, if that's the correct verbiage. Carlos would be able to do 1/6 of the job in a day. What we're trying to find out is how much of that job could they get finished in a day if they all work together. So I'm going to have to go through here, find a least common multiple, work this out. Easiest way in this case, especially if you get a decimal or a fraction there, is just to multiply everything together. So let's see what our multiple is going to be. 4, 5.5, and 6. 132. So 132t, because I also have a t in the denominator, is what I'm going to multiply through by. And I'm going to go fraction by fraction, working this out. 132 divided by 4 is 33, but the t doesn't cancel, so keep the t. 132 divided by 5.5 is 24. 132 divided by 6 is 22. And for my last one, the only thing that cancels is the t. So, add these guys up. 79t. Yes. Divide by, that's 79 with the t. And it looks like, to me, if they all work together, they could knock this job out in about 1.67 days. Which makes sense, because you would hope if they were working together it would take less time than the fastest person. Now if you did this and it said it would take them like 11 days all together, it's like they must party when they get together and not do any work or something, because that wouldn't make much sense. So those are the types of things that I have to think about a little bit on reasonableness of my answers. Last one. All right. Carlos and his friends rent a car. Maybe that's why it took Carlos so long to do the painting job. They split the $200 rental fee evenly. Carlos, together with 2 of his friends, decided to rent a portable DVD player as well, and they split the $30 rental fee for the DVD player evenly among themselves. Carlos ends up spending $50 for the rentals. Write an equation. Use n as the number of friends Carlos has. Solve the equation for n. Okay. So we got a car. $200. When you're splitting the cost of something up with somebody, what are you actually doing? We're dividing. So we're going to divide 200 by n because everybody split the rental for the car evenly. However, on the DVD player, there's 3 people. So I could just write that as 10, but so I can see what I'm doing. Took the $30 rental fee, divided it with 3 people, 2 of his friends and him. And then Carlos ended up spending $50 total. So this makes sense. He spent whatever part of the rental fee, divided amongst the people, and 1/3 of the $30. Okay. So we're going to multiply through by, well, at least kind of multiple, my 3n. And we're just going to go from fraction to fraction, knocking this out. So here the n's cancel. So 3 times 200 is 600. Here the 3's cancel. So I'm left with the n, so 30n. And in this last one I have everything still. So 50 times 3n is 150n. Get all my n's together. And we find out Carlos has 5 friends.
Okay, I feel like I took the lazy route.
Okay.
I took the 10 from the 30 divided by 3, got 40. I multiplied by n, 40n equals 200, then I got 5%.
Perfectly reasonable.
Okay.
Yep, perfectly reasonable. So, your task. This book page on the bottom will be the last part for our homework check, which is coming Friday. You're like, dang, these homework checks just come non-stop, Harty.
Homework check, wait, what were 1 and 2 for homework check 7?
The more graphing rational functions and that Unit 5 extra practice. So what we were working on back on Monday would be the other 2 worksheets that are involved here. Okay?